All
right, friends. All right. So we just finished Euler circuits and paths.
I still don't understand that.
We are about ready to start Hamilton circuits and paths. So Euler says that every edge is used exactly once, which means by definition, each vertex can be traveled more than once. Okay, so in other words, you can go to Walmart as many times as you want, as long as you take a different way to get there. Okay, that's what Euler says.
There's only like
your tags back.
To be honest, there's 1, 2, 3. There are only 3 ways to enter Walmart.
So there you go. You only have
like drive into to the marketplace. Yeah.
According to Euler, then you only have 3 ways to get to Walmart.
You technically, it depends on what you're driving.
Man, I'm not about to drive under no damn speed bump. You got me messed up. Not about to mess up my car.
Oh my god. Okay.
4 ways because you can come from the project.
That's what I'm trying to say.
But you can't drive a car through the project.
Yes, you can.
I was thinking about driving.
Man, you don't even have to drive. You can walk.
I know.
Right, yeah.
Or drive it.
But see, I was thinking about driving, so it's okay.
So, Hamilton says, I don't care about how to get there. Okay, I just want to get there. Okay, so Hamilton says I'm going to every vertex once and only once. So you can take whatever road you want, but you're only going to Walmart once.
Oh no.
Okay, you're only going to Sam's Club once. You're only going to Wendy's once. Okay, so with Hamilton, every vertex is used exactly once. You enter and exit one time. By definition, not every edge needs to be used.
It's kind of like me when I'm going grocery shopping, like food stamp shopping. I hate
Listen, Miss Smith was that person even when she was in college. She only goes to Walmart at like midnight because there's nobody there.
Right? I absolutely love that.
This is what you do. You get up at if you're not an early bird, get up at 9 o'clock. Get your shopping done by 10. Because that's when by 10:30, that's when everybody's starting to come out and get up and people's eyes is getting that crust removed. Feel me? By 11:30, you should be done with everything.
She said people's eyes are in the crust removed.
Okay. So, remember, Euler said I can count the degree of each vertex. If I have all even degrees, I have an Euler circuit. If I have all even and exactly 2 odd, I have an Euler path. If I have anything else, neither. Okay? Unfortunately, Hamilton doesn't have anything special like that. Okay? But we'll figure it out. So, if you look at graph number 1, would you consider this an Euler circuit or an Euler path, according to the last chapter? Drew says an Euler circuit. Okay.
I said,
I'm sorry, he said an Euler Okay. He was getting ready to say Euler circuit. He is absolutely correct. Okay. So take a look at this. A has a degree of 2. B is 4. C is
4.
D is
2.
E is F is
4.
G is. So they're all even, which makes this an Euler circuit.
PC.
Okay. So, unfortunately, there's no special rule that helps us with Hamilton paths or circuits.
Great.
Okay. I can't count them and just assume. So, in order for it to be a Hamilton circuit, I need to start at a point. I need to trace lines, go to every point, and go back to the beginning. Can that be done in this graph?
Yeah, if you go to D twice.
Yeah, you have to go to 1 or 2 of these lines.
Can you go to them twice?
Can't go to a place
no,
twice.
It's impossible.
Or circuits.
I mean,
let's just start it.
Listen though, you don't have to touch every edge.
oh
You
well.
don't have
No, you don't have to touch every edge.
So you could just.
You could just
Oh,
do
yeah.
A, B, C, D.
Yeah.
So I should be able to do this.
A,
I
F, G.
A, F, G, E,
Oh.
D, C, B.
Ah,
That's it.
Excellent. I was like, you can do D, A, B, C.
Okay, so I can do a Hamilton circuit. Again, you don't have to touch all of the edges. So this is a yes. Okay, if I have a Hamilton circuit, I automatically have a Hamilton path. Okay,
Why?
remember, a Hamilton path just means I start and stop at two different points. I still have to touch every vertex, do not have to touch every edge. So if I would just get rid of this line that connects B to A, that's a Hamilton path.
Okay.
I just stopped instead of continuing on back home. Okay, does that make sense?
Where'd you?
So I left A, which is home. Okay, we went to F, Walmart. We went to G, Sam's Club. We went to E, we were hungry, we went to some Taco Bell. We went to D, the gas station. We went to C, where we go? No,
Van Dome.
we go into the club. Okay, we go get our boogie on at the club. Okay, we then go to B,
Which is your best friend's house.
church to pray for y'all. Okay,
She said.
we just don't go back home.
Facts,
Okay.
barbershop,
So we stay at
barbershop.
church. We just stay at church.
Oh my. All right. Let's take a look at graph number 2. Okay, again, Euler. We need to count the vertices to see if I have a path or a circuit.
It's a path.
This one is a path. A has a degree of 2, B has a degree of 2, C is 2, D is 3, and E is 1. Sorry, 1. So I have exactly 2 odds and the rest are even. This is an Euler path. Okay. Okay. Can we manage to do a Hamilton circuit or a Hamilton path?
Yeah.
Not the circuit.
Not the circuit.
Yeah.
He says no circuit, but I can do a path.
Yeah.
I can do a path, sure.
A Z. Oh, you said they all don't have to touch.
I don't have to touch all the edges. I just have to touch all the dots.
Do a Z.
Okay, you could have done a Z too. That works as well. So there's multiple Hamilton paths. I could do this. Okay, so yes, I have a path. But unfortunately, no, I don't have a circuit. So again, if you have a Hamilton circuit, you automatically have a path. However, that does not work in reverse. If I have a path, that does not guarantee that I have a circuit. Okay, take a look at graph 3. Do I have a Euler circuit or path? No.
Nah, you got.
No, I don't have anything. I don't have anything. This is A is 3,
They're all
B is
three.
3,
Except
E is
for C
also
is
3.
four.
As soon as you hit that third odd, I have nothing. So that's a no. I have neither. Do I have a Hamilton circuit or path in this one?
You got a path.
You got a path?
Yeah, you can make a Z. Again.
Okay. So I agree. Yes, I have a path. Can anybody find me a circuit in this one?
Yeah.
Yeah, I got it.
What you got?
A, B, E, up to C, D, back to A.
There is also a circuit in this one.
Wait, what did he say?
Okay. He said A, B, E, C, D, and back to A. You could have also went A, B, C, E, D, and back to A. Okay. There are multiple circuits in this one. But I do have a path as well as a circuit. Graph number 4, Euler. Do I have a path, circuit, or neither? This one should be a circuit. They are all even degrees. So this is an Euler circuit. Okay. Do I have a Hamilton circuit
No,
or path?
you don't have a circuit.
Okay, Drew says no circuit. Do we have a path?
Yes.
Yeah. We can draw that Z
We
again.
can draw-
Zorro. I was thinking Drew's. That's why I said we can drew it. We can drew it instead of draw it. Okay. What about graph number 5?
I don't know.
Euler. Path, circuit, neither.
It's an Euler. So what's the one without one odd? Is it EP?
2 odds.
It's
Yeah,
a
two
circle.
odds, right?
2 odds.
It's
That's
a path.
EP.
Yeah.
That's a path.
'Cause they
Okay.
got one that-
All of them are even except for A and D. So this is an Euler path. Do I have a Hamilton path circuit?
Don't have a circuit.
Okay. Drew says no circuit. Can I do a path?
No.
Can't do a path either. Even if you try, we go like E, B, C, E.
You would have to hit B again.
You'd have to hit something again. Okay? It's just not going to work. Graph number 6. Euler. Path, circuit, neither.
It's the same.
Oh wait, you can do a path. Oh wait, I'm skipping.
You're doing Hamilton?
Yeah.
Okay. Hold up on me, Gianni. What about Euler?
It's 4 odds.
There's 4 odds. So what does that mean for Euler?
That's not, you can't do that.
That's a neither. Again, all even circuit. Exactly 2 odds, path. Anything else? You have nothing. Okay? So Gianni says, yes, we have a Hamilton path.
Yes, we did.
I agree. I can go.
That's what I did. That's exactly what
Is it? Do I have a Hamilton circuit? No. Okay. Unfortunately, with these 2 bridges, that causes us to lose that Hamilton circuit. Okay. Those 2 bridges causes us to lose that circuit. So, do you notice the relationship between graph having a Euler or an Euler circuit or path or a Hamilton circuit or path?
Euler
Is
circuits-
there any type of pattern going on
Euler
here?
circuits have yes to everything. They use Euler circuits.
Mm. Euler circuit had yes, yes here.
No.
Yes, no here. Okay. Unfortunately, there is no relationship between the 2. Okay. There is none. Okay. So there is none. All right. So-
I'm correct. There's no relation.
No relation. Okay. So we now are going to have to write Hamilton circuits. Okay. So I gave you your first Hamilton circuit. I can go and start at A.
I hate this.
I can travel to B, to C, to D, and back to A. That's here. We have something, they're called same circuits or shift circuits. Okay? You're following the same order of the original with this, except you have a different start. So, what I mean by that is I can shift over and start at B. I still want to follow the same pattern. So I go B to C to D to A and back to B. Okay, that's called a shift or a same circuit. It's no different. You're not going in a different order. You just start at a different place. So instead of starting at home, if we call A home, we go to Wally World, Walmart, we go to the gas station, and we stop at Taco Bell. I don't know why I have tacos on my mind right now. Okay. So I've got 2 more shift circuits. I can also start at the gas station. I can leave the gas station, go to Taco Bell, home, Walmart, and back to the gas station. Don't ask me why you'd want to return to the gas station, but, you know.
Like a phone account.
Okay?
Honest answer.
Or finally, I could stop at Taco Bell first. Okay, so we could do Taco Bell and then go home, go to Walmart, go get some gas, and go back to Taco Bell.
Because you had to pick up your husband from his other job.
There you go. You had to drop them off, go home and feed the dogs, go grocery shopping, go get some gas, and pick up your hubby on the way back.
He had a short shift.
All right, maybe you went home and took like a 6-hour nap. Then went grocery shopping, got some gas. All right. Okay. So those are the same. When they're asking you to do distinct circuits, which are different, which means you stopped at different places in a different order. Okay. So whenever you're doing distinct, you always want to start at A to make sure that you're doing a distinct path. Now, as soon as you get a Hamilton circuit, going in the opposite direction is automatically a distinct graph. So what I mean by that is this went home, Walmart, gas, Taco Bell, home. I can also go backwards and go home, Taco Bell, gas, Walmart, and back home. That's your first distinct Hamilton circuit. So once you get one circuit, you automatically have a second circuit. Anybody come up with a different way to travel this?
CBADC.
Home, Walmart, gas, Taco Bell. You said what?
CBADC.
Careful. Distinct, you always want to start with the same letter. So we want to start at home. We just want to go in a different way.
ACBDA.
Okay? ACBDA. So that's home, gas, Walmart, Taco Bell, and back home. Okay? So she went A to C. Hold on. A to C to B to D and back to A. So this is the path she took. The first one we went like this. Okay? Again, I can take that, flip it and reverse it. So I can go A, D, B, C, A. And that's the same picture.
A, B, C, B,
Okay? A, D, B, C, A. You said A, B, A, B. We already had that one. That was the first one I gave you. There should be one more though. A, C. You said A, C. Be careful, you have to go to every spot.
ACDBA.
ACDBA. Okay, so ACDBA goes here, 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 and here. See how that changed your path?
Yeah.
Okay. Again, I can also go in reverse. Okay. So you have 6 distinct Hamilton circuits. Again, when they ask you to list distinct, you always want to start from the same point. That way you make sure that you're not just doing a shift. You're actually giving me something different.
Oh, what a delay.
Right.
Nice, sunshine.
Oh, that jumped up and slowly.
Okay. So let's see if we can come up with the 8 distinct circuits in this picture. Okay. I need somebody to give me one.
One what?
Give me a distinct circuit. I've got to touch all the dots.
E, F, G, A.
A, B, C, D, E, F, G, A.
He's bugging.
A, B, C, D, E, F, G, A. Again, once I have one, I automatically have 2. I can write this in reverse. A, G, F, E, D, C, B, A. Third period said I was screwing up their alphabet. They can't remember the alphabet anymore. They were like, how's the alphabet go? A, D, G, Z. I'm like, come on now. Right, they get a little too extra. They get a little too extra.
I don't think anybody does.
Okay.
Where my butt go?
Anybody have anything different that I can do?
A, G, E, F, C, D.
That's not gonna work.
I feel like old dudes.
You said AF.
C. B.
You said B or D?
No, go AF.
Hold on.
A-
Gianni is talking. Please stop.
AFCB. Hold up. Nah,
AFC.
No, go ahead.
oh wait. Okay. AFC to what's the one at the bottom? I can't see it. Is that an
E.
Yeah, E.
Okay.
Then a B. And then
No.
D.
You can't get to D. There's no line that goes to D.
I mean G. And then A.
No, Gianni.
But you didn't touch D.
Wrong.
Doesn't work. Doesn't work. Next try. All right, Zoe. Hold on. Let me erase this. Okay. All right. Go ahead, Zoe.
A, G, B, D. I'm sorry.
Yeah.
I mean E,
Okay.
F. Fuck.
How you gonna get back?
Oh, you shouldn't record this class.
You should watch your language.
A G B.
That's not
To
gonna work
E.
either. Hold on.
Just go
A, G,
B
B
to E.
to E
That's what I just did.
to
I
C
didn't.
Okay, go off.
Shut up, Zoe. You messed
I
me
said
up.
go off.
To D.
You messed me
to D.
up. How you gonna get to F, bro?
Ooh.
Watch your mouth.
I didn't say.
Gosh, I swear I'm getting soap for this class.
I said 4.
Fudge.
A,
You got one? Carla's got one. Let's go, Carla.
A, B, E, D,
A, B, E to D,
C,
C.
Okay, I respect it.
G,
All right, Carla's got one. So we're going A to B, to E, to D, to C, to F, to G, and back to A. So she got us 2 more, because again, I can write this one in reverse. A, G, F, C, D, E, B, A. Sad part is we got 4 more. Whew. Well, technically we have 2 more and then the reverse. Technically.
Right now.
All right? Somebody find me another one. When you got it, put your hand up. We'll do it.
You know, right? You know, right?
Come on, Devin.
This your thing yet?
I got one.
Drew got one? All right, Drew, come on. If you don't get it, we'll go to Carla.
A to G to F to E.
A to G to F to where?
E
E.
to D to C to B to A.
A, G, F, E, D, C, B, A. Unfortunately, we already have that one. That was the reverse of what you did in the first place. Okay? What you got for me, Carla? A to F, C, D, E, B. All right, so we went A to F, and we haven't done A to F yet. That is perfect. So we got A to F, to C to D, to E to B, to G, and back to A. And then we've got your reverse. A, G, B, E, D, C, F, and A.
Do we have to do these different times? Do we have to do these every time?
The reverse?
Yeah.
Yes.
But do we have to do all these? Or can we
If
do
it
one?
asks you to list all of the distinct circuits, yes, you need to list them all.
All right. Then I ask you that over the test.
Oh no.
Is it too late to change the calculus?
Bye.
Hard day.
Good luck. Miss Wells is going to make you go back and do everything from the beginning of the year.
Man, anybody going to
That
this
includes your
class?
summer assignment that's like 30 pages long.
Yes, sure.
What was your question, Jonathan?
Is it gonna make us do that on the test? List all of them?
This is dummy smart.
That should be the bonus.
What'd you say? Oh, okay.
I honestly don't remember, but I will print the test so I can answer that. Your final exam, I have yet to see anything Hamilton Circuit on a release test.
Hey, honestly,
But again, I don't actually get to look at your final exam because I don't give you yours, because then I could cheat and give you the answers. So
Yeah, you better.
I don't know.
And I hope it's on paper.
I want one of them teachers.
The
that-
final exam?
Yes.
It's on the computer.
Can you switch that to be on the computer, on paper?
It's a
Nobody
state
likes-
exam.
Nobody like to take
I'm-
exams on the computer.
I'm sorry. It's a state exam. Who can find me my last one? Oh, Sacramento got me. All right.
I don't know.
A,
First one, friend. A. You said what? G. B. C. D. A. G. I'm just making sure it doesn't. To B. To C. That's perfect. He got it. A to G to B to C to D to E to F to A. And again, reverse. A, F, E, D, C, B, G, A.
Why did we do the A, B, C, D, E, L, G, A? Oh,
We did.
my fault.
We did. You just missed it. You zoned out.
I'm tweaking.
Jesus.
Came up with them all. Okay? So, tell me this. If I have 8 total distinct circuits that start at A, how many circuits would start at B, C, D, E, F, and G? 8. Okay? So, if I have 8 that start at one letter, that means I have 8 that starts at any letter that I want to start
There
at.
are 8 possibilities, period.
Period.
Technically,
Period, 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 period.
So how many do we have total?
All right, you sound like my dad. Period. I'm just tired. Period. I'm just period tired. Period. Period.
Okay?
Exclamation mark.
Exclamation point. No, that means factorial.
A, B,
Okay. We're using the graph off to the right here. Find me a Hamiltonian path that begins at A and ends at E. Again, I must touch every dot. Do not have to cross every edge.
Got you.
What you got, G? Oh, wait, Jonathan's got one. He has it.
Hey,
Let Jonathan go. What you got?
A, F, E, C, G, D, E.
A.
Bro, you really think like me?
A, F, what?
A, F, B,
C,
G, D, E.
That works. A, F,
See,
B, C, G, D, E.
there's no other way. Because you can't go from F to E.
All right, smart pants.
That's what I'm saying. Like, it's still mine. That was mine.
Oh, no.
Could've did it first.
Like, bro, you about to cry.
Hey, take a look at B. Now I want to make that into a circuit. I want to start at A, and I want to finish E, A.
So do the same thing we just did.
Do the same thing we just did, except from E, go to A. So it's the same as your path, except instead of stopping at E, I'm going to continue on and go back home. I'm going to continue on and go back home. Okay? Find a Hamiltonian path that begins at F and ends at G.
F, D, D, G.
You said F.
Oh, no, it has to hit every
It has to hit every point.
I got you.
All right, G.
I lied.
Go ahead, G.
Oh, no, I got you. No, I lied. No, I got you.
F-A-B.
I got you. I lied. I got you. I lied.
I got it.
Drew got it. Go ahead.
F, A, E, C, B. Oh,
E,
that's up, never mind.
C. Yeah, you gotta go through
F-A-B.
F-A-B,
C-E-D-G.
C-E-D-G.
Yeah.
That works. She's fab. F-A-B, F-A-B, C-E-D-G. There was more than one way to do that one. That's okay. Okay, example number 3. The following graph, so this one off to the right here, has no Hamiltonian circuits or path. Why not?
Because it's the same thing.
It's lines.
This lines.
They got what's the name?
Oh, because
What?
they're all.
They got what's it called?
They're all
Touch 'em
even.
all.
You tell me.
I forgot what it's called. Yeah, bridges.
You've got too many bridges. I've got a bridge here, a bridge here, a bridge here, and a bridge here. I've got way too many bridges. Remember, when I cross that line and go out to that dot, I'm not going to be able to go back.
Exactly.
Okay? So, we have 4 bridges. Okay, I've got 4 bridges. Just not going to work. Okay, we've got one more example. Somebody, see if you can look at the next example. We need to come up with 6 distinct circuits.
That's how you feel.
Okay. We need 6 distinct circuits that start at A.
I got you.
Take a minute, see if you can find them. Remember, once you write it once, you can also write it in reverse. G, what you got for me?
A to B,
A to B,
E to hold up, E to D, F to C,
And then back to A. Oh yeah, you got mine backwards.
so A, B, E, D, F, C, and back to A. Again, I can reverse that. A, C, F, D, E, B, A. Johnny and Drew think alike.
Right minds, we think opposite.
Oh,
Do you write
so-
like a 3rd grader too?
Bro, she said think. And that has nothing to do with handwriting. Oh, if you do, then I ain't mad.
FYI, who's calculator 25 in here? It's sitting over here now because I now have a 26, 27, and 28. That way it's easier for me to count and make sure everything's here. So it just sits on something else for 2 books over here.
Do you teach algebra too? What?
Technically, yes. Technically, and because we do math 1, 2, and 3, we teach a little bit of algebra 1, a little bit of geometry, a little bit of algebra 2, a little bit of trig. We do it all.
I fucked that one up.
Oh,
I got one.
Nehemiah, is this yours?
You teach algebra 2.
Or Timothy, is this yours? Because it has your name on it.
Oh, that's mine.
Okay.
Algebra.
It was in here, I think, like last week, and I said it over there, and I completely forgot about it.
I got another. A, B, F, E, B, C around.
Whoa, you said A, D, F, E, B, C, and then back around. All right. So we got A, D,
All 6.
F, E, B, C, and A. And then we do A, C, B, E, F, D, and back to A.
FDA.
There should be one more, and it's reverse.
A to A to C. Oh no, we already got
A, B, F, C, B around.
You said A, B,
A,
what?
C,
A,
F.
D, E, F, C, B around.
But you forgot about D.
A,
Yeah,
B,
if you go
A, D, F, I mean, E, no.
A, D, E, F.
E, F, C.
A, D, E, F.
and
C,
around.
B, yeah.
Okay. A, D, E, F, C, B, and back around.
Yeah.
Okay. Good. A, D, E, F, C, B, back to A. And it's reverse. A, B, C, F, E, D, A.
So that's our 6.
Okay. So those are all the ones that started A. You told me that means I also have the same amount that started D. So all you would have to do is take these and reorder. So this one I want to start at D. So D
F,
leads
C.
to F, which leads to C, to A. We're back at the beginning now. To B, to E, and finally D. And you'd have to reverse it. I'm not going to write it. Okay, you would have to reverse it. So D, E, B, A, C, F, D. Okay, you can reorder this second one. Again, you just have to start at where they want you to. So this second one would go D, F. EB, CA, and back to D. And again, the reverse. So I could do DAC, BEF, and back to D. And the last one, if I want to reorder it, DEF, CBA, and back to D. And again, reverse, DAB, CFE, and D.
CFE.
Okay, so these 6 are the exact same as these 6, which is why I tell you when you do distinct ones, make sure you're starting at the same letter, because that will give you the actual distinct ones. You have too much of an issue with just reordering what you already have if you skip to a different letter. Okay.
Oh, you don't have.
Questions?
Oh, you
Problems?
can school out here.
Are you asking for
That's right. I remember.
Why you asking?
Don't come and do that.